So I told you we were going to have to graph, and here it is. So in the velocity section, you're going to make position time graphs. And these are graphs where time is on the x-axis. Okay, so you have time on the x-axis and position on the y-axis. Okay, now do you guys remember when we talked about independent and dependent variables? This is pretty key. Okay. Now there's a couple things that we said. We said the independent variable is always on the x-axis, and the dependent variable depends on the independent. So when you have time, it's really easy because time is always independent. Always, 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 always. Okay, but you can think, does your position depend on the time, or does the time depend on the position? Okay, now time keeps going regardless of what you are doing. And so your time or your position depends on the time. Okay, the longer you're running, the farther you're going to have run. That kind of thing. Usually they'll give you a little table like this where they have some time points and some distance points, and they're just going to want to make you draw them or plot those. Okay, so like for this one they had 0, 0. The next one they had 1 and 5, and so on and so on, and then they connected the dots. Okay, on a position time graph, you will connect the dots unless they tell you not to. Okay, so this position on the y-axis, time on the x-axis, and then your slope is going to equal the velocity. Okay, if you want to get the instantaneous position of the runner, you've got these right here, right, that you've plotted, but you could just as well say at 1.5 seconds, where was the runner? And you can, so here's one going up, and I'm going to go over. He was about, what, 7, 7.5, something like that. So you can figure out the instantaneous position of a runner using a graph like this. Okay, so now here's a problem they might give you where you have to interpret a graph. They say, when did the runner, whose motion is described in the graph below, reach 30 meters beyond his starting point? Okay, so they want to know when his distance was 30 meters. So you can just kind of like go across, or what time when his distance was 30 meters. And it's this point right here, this point right here. See, I'm not very good at drawing straight lines, is at 6 seconds. So at 30 meters, he was 6 seconds. Okay? And then it says, where was he after 4.5 seconds? So you look at your graph, it's labeled really nice, 1, 2, 3, 4, 5, and they don't give you 4.5. Okay, but you do know that 4.5 is halfway between 4 and 5. Okay, so you can, and it's okay to draw these lines like I'm doing. You don't have to eyeball it. I know sometimes that's hard. So 4.5 is right about here. And then if we draw this across, you can see that your person was halfway between 20 and 25. It's like 22.5. So at 4 seconds, 4.5 seconds, he was at 22.5 meters. And that's all you have to do to interpret one of these graphs, where they already drew it and then you have to figure out something from the graph. Okay? Now, if we're going to graph velocity, there's a couple things that we can see with the slope, which is really handy. They don't tell you anything. Right? This is distance, this is time. It tells you nothing about velocity, but if you plot those points, you can actually see some really important things about the velocity once you've drawn the graph. If your graph has a positive slope, it's going to have a positive velocity. If it has a negative slope, it's going to have a negative velocity. Now this is where people usually get that part, okay? If you have a curved line up, that means whatever object you have is getting faster and faster, okay? If you have a curved line down, that means whatever is moving is going slower and slower. And then if you have a completely horizontal line like this, okay, let's say this distance is 5. If it's horizontal like this, it's 5 the whole time. So that means it is stationary. So if you have no slope, your velocity is 0 meters per second. Okay, this could be a car that is driving at a steady speed. It hits a stoplight, so it stops, and now it's going backwards where it came from. Okay, but if you have a horizontal line like this, your speed is 0, your velocity is 0, which is really important because a lot of people get that confused. They say that's a constant velocity, which is not true. Okay, now this is another one. They've already drawn the graph for you, but they want you to figure something out from the graph. So they have runner A and runner B, and they want you to find out when runner A, where runner B passes runner A. So you can see runner B starts behind, 50 meters behind runner A, and then runner B is a faster runner, so you can see that at this point right here, where the two lines cross, and then runner B is kind of ahead, that's where runner B, this point is where runner B overtakes runner A. And then from this point on, runner B will be in front and runner A will be behind. So again, that's a graph that they've given you. You don't have to draw the graph, but you do have to understand what's going on in the graph.